Hello, eighth grade students. Thank you so much for being so patient and so willing to try new things and do a little bit of learning online. I have put together a little video of me going through all of these questions on set E. I'm going to do a little screen share for you. Um, so it looks slightly different from when you looked at it, but on set E, you had these questions about balancing these equations, and I was asking you to put in your a answer in here using that represents each of those coefficients. Those coefficients, if you didn't get it typed in exactly correctly, you were marked wrong. But so my video is going to kind of walk through each 26 through 30 as this video. And if you click on the next video, it's just me starting right in doing these challenge questions. If you have any questions in the meantime, please be in touch. And again, I really appreciate this time we've had together to me learn a little bit about online teaching, and let me know if you have any questions. We'll be in touch.
All right, so bear with me as I have a little bit of my neighborhood sounds in the background. So I'm going to go ahead and go through these different problems for us. So I'm going to start out with this problem, this mercury with some oxygen and gives us mercury oxide. I'm not going to go too deep into the naming, but this is one of the problems on there. So I'm going to start off with the way that I've shown you how to set things up. I'm going to set up first, I'm going to have that mercury, and then I'm going to have an oxygen with a H, and each side, remembering that each side is going to represent how many we start out with when you're just looking at this unbalanced equation on both sides. So we got mercury, we've got 1, we've got 1, and then oxygen, we've got 2, and the other side we've got 1. So then you can already see we're not balanced. We're balanced with the mercury, but not with the oxygen. So then we need to think, what number are we going to be putting in front of this compound of mercury oxide in order to make this have 2? If you thought 2, you are correct. So you can go ahead and put 2. And then that would change that to 2, because that 2 then distributes not only to the mercury, but also to the oxygen. So that's also going to be 2. And then that then puts the mercury off balance. So then we have to think about what number we put in front of here. We would put a 2. So then we would have then a balanced equation. So then the answer for this one would be 2, comma, 1, comma, 2. So that's what you would expect for that one. So moving on to another problem. We got myself some scratch paper. So the next problem, we have number 27, which was, we got this iron 2 chloride with some sodium carbonate, gives us some iron 2 carbonate with some sodium chloride. So this one is certainly a little bit trickier than the previous one. For this one, I'm gonna give you a little hint. If you see what we call a polyatomic ion, you'll learn more about that in 9th grade chemistry. But if you see what we call a polyatomic ion, the little cluster of atoms together, a CO3, just like we see on this side, we see a CO3. We can actually keep that as our little cluster. And so you're going to see that I'm going to do that whenever I break this all up. So we have an Fe, we've got a Cl, we've got an Na, and then we've got a CO3. The CO3 is going to be on both sides there. So, going to keep trucking through. So, trucking, I don't know why the heck I just said trucking, but we're going to keep going through. So, we're going to count. We've got 1 iron, we've got 1 iron, we've got 2 chlorines or chlorides, we've got 1 chloride on this side. We've got 2 sodiums, we've got 1 sodium. We've got 1 what we call carbonate, or in this case I'm just going to call it CO3. We've got 1 CO3 and 1 CO3. So you can see that it is not balanced. So then we need to think to ourselves, what number can we put in front of this side? We have to choose the side where we have the less number of atoms. So here we have less chlorines than we do on this side. So then we need to, so kind of following the suit of being able to say, okay, we've got 2 chlorines on this side, we got 1, so we need to put a number in front of here in order to make this balance. So we'll make it balance by putting a 2 in front. So that changes to our chlorines, the 2. And that also then that's going to apply to that sodium. So just by choosing one of them, we've actually already balanced it. So if I was to write this as for the answer for this one, you're going to see there, so that would be 1, comma, 1, comma, 1, comma, 2 would be the coefficients for this balanced equation. So then moving on to another one, I'm going to move on to number 28. Number 28, we've got this silver nitrate and magnesium chloride is going to give us magnesium nitrate and silver chloride. So similar to the last one, I have this little cluster of NO3s. I have a cluster of NO3s on this side. I can actually keep them together. These clusters are called polyatomic ions. Again, you'll learn a little more about them later. So I'm going to separate this out. We've got AG, NO3. We can keep that NO3 together. We've got Mg and Cl. Going to count through. Got 1 on this side. I got 1 on that side. I've got NO3. I've got 1 NO3 on this side. I've got 2 NO3s on this side. So Mg, I've got 1 Mg. I've got 1 Mg on this side. And then I've got a chlorines on this side. I've got 2, and I've got 1, a chloride. It's not a chlorine. And so here you can see that we're not balanced. Again, you can choose any place. We could choose at the chloride, we could choose at the nitrate, or in this case I'll call it an NO3. So I'm going to go ahead and choose to go for the NO3. Let's balance this one. So we need to go on the side, on the reactant side, we need to put a 2 in front of the AG. So that's going to change our AG to 2. That's going to change our NO3 also to 2. So we got our NO3s are balanced. But now check this out. Now we put our silver off balance and our chlorine is still not balanced. So I'm going to just go ahead and keep staying with this same one that we had before. So I'm going to go over here. Now I've got 2 on this side. I've got 1. If I put a 2 in front of this AG, this 2 is going to apply to the AG, so that's going to tell us that we have 2 on there. And then we've got that 2 is also going to apply to the Cl, so that's also actually going to fix our Cl. So to map this all out, if I was going to ask you about the coefficients, you would write, for this one, you'd write 2, comma. For this one, there's an imaginary 1, so 1, comma. Also imaginary 1, comma. And then a 2. So that would be the answer for number 28. Moving on to another one. Here in a moment I might need to start reusing some of my scratch paper, so bear with me. So number 29, we've got NABr with CaF2 and gives us some NaF and a CaBr2. So with this one, we are also going to follow through the same method. We got Na, we got Br, we got Ca, and we've got F on there. Please bear with me also, I'm using a tripod kind of at a funny angle, so I'm trying my best to make sure I can kind of squeeze in here, so please excuse the kind of slightly messy writing. So we're gonna go ahead and dive in here. So we got Na, we got 1 on this side, 1 on that side. Br, we've got 1 on this side, we've got 2 on that side. Ca, we've got 1, Ca, we've got 1, and here we've got 2, and here we've got 1. So as you can see, both of our anions on this case are not balanced. So we've got the bromines aren't balanced, or the bromides aren't balanced, and the fluorides aren't balanced. So we can choose anywhere. I could choose try to balance on this side. I could choose to balance on this side. I like to go in the order of how things appear, just to kind of keep my brain organized so I don't get lost on kind of what I'm doing. So what I'm going to need to do is I see there's 2 on this side, and there's only 1 on that side. So I'm going to go ahead and put a 2 in front of the Na. That's going to fix our Br, because that's where we're focusing. But also we need to think back, that's now going to affect that Na. So now we've put that Na off balance. But staying with the similar one that we had just had, I'm going to come back, I'm going to balance off that Na. If I put a 2 in front of this NaF, that 2 is going to fall into NA. There's 2 on each side. And then check this out. That now that 2 is going to affect that F. So that's also going to be balanced. So we got 2 and 2, 2 and 2, 1 and 1, and 2 and 2 balance out. So if I was to ask again about these coefficients, we had 2, comma 1, comma 2, comma 1. Those would be the coefficients for that balanced equation. All right, time to start reusing some of my scratch paper. So I'm going to fold this one in half. So here is for our last problem that was me asking the required problems for this assignment. So this one was maybe a little tricky for folks, but maybe you were able to figure it out. This one, so we just have 2 different atoms that we're gonna account for here. We got S and we got O. So we've got 8 and we've got 1. We've got 2 and we've got 3. I will have to say, anytime you have an odd number on one side and an even number on the other side, it's going to be a pain. But this one's not much of a pain as some of the ones I'm going to show you on the challenge questions on the other video I have for you. So, go right in. So here we've got 8 on this side, 1 on this side. The only way we can really figure out where to go is we need to put an 8 in front of this SO. So then that S, now that sulfur has 8. And now, this does not mean that there's 8 oxygen. We need to account for the fact that this SO3 has 3 oxygens. So 8 times 3, what's 8 times 3? It is 24. So we have 24 oxygens on that side. And so then we need to think, okay, we have 2 here. We can't change the subscript. Remember, you can never change this. We can only put a coefficient. We can't just put this into being 24. That would be awesome, but that's not reality. So what number would I put in front of here? If you were thinking 12, you are correct. So I will put the number 12 in here, excuse me, as I squeeze that there. And then 12 times 2 is 24. It's a little bit of division on this part, but hopefully not too bad. So if I was to ask you about the coefficients on here, there's an imaginary 1, so this would be 1, this would be 12, and this would be 8. So those are the balanced equations, and if you went ahead and tried the challenge questions, go ahead and watch the other video, and hopefully we can answer some questions for you. Enjoy.